the next important theorem related to derivatives and local behavior is Rolle's theorem. Okay, and it says, suppose f is continuous in this closed interval AB and differentiable in the open interval AB, such that f at A and f at B are the same. Okay, so it's a function that makes something like this, but the value at A and the value at B are the same. Well, the theorem says then exists a C in this interval where the derivative at f is 0. Okay, so for instance, this point here, or this point here, or this point here. Okay, what it says is at least one of them. Okay, let's see. How can we prove this? Well, what we need is to use the intermediate values theorem that we saw in last unit for continuous functions in a closed interval. We know that in AB, right, the function will reach a maximum. Okay, let's see. Let's call x m and x capital M, a minimum and a maximum. Okay, that will belong to this interval, right? Okay, so let's see. Suppose there are some cases, right? That the first case is that both the minimum and the maximum are in this open interval, right? Well, if they are in this open interval, that means that they're extremum in an interval in which f is differentiable. So applying the previous theorem that we have just seen, then the derivative of x at xm and the derivative of x at x capital M is going to be 0, right? Applying the previous derivative. So we're done, right? Well, it could be the case that either xm as xm is a, or x capital M is a, and the other one is at some point C in the wait a minute, in the open interval, right? Okay, so it's either it's A or B. Okay, so one of them, either the minimum is at one of the extremum of the interval, of the ends of the interval, and the maximum is at the middle, and the other way around, right? So we can have two possibilities here, right? Well, if that's the case, then the value of the derivative here is going to be 0, and the value of the derivative here is going to be 0, right? Because applying the same theorem, right? The function is differentiable in this open interval, and it's reached an extrema here, right? So that's the second possibility, right? The third possibility is that the maximum is at B, for instance, and the minimum is at A, or the other way around. The minimum is at B, and the maximum is at A. But now the thing is that we know that the function has the same values at FA and at FB, right? And so that means that the minimum and the maximum are the same, right? F at xm is equal to f at xm. But we know that this is the smallest value that it has, and this is the greatest value that it has. So that means that f is constant in this interval. Okay? And so that means that if a function is constant, we know that the derivative f prime will be 0 for all c in this open interval. Okay? That's the three possibilities that result in us having a point C where the derivative is 0. Okay?